Hey, good evening, guys.
Hello.
Hey,
Hello.
Jamie. Hey, Nico. What would you guys like to work on today?
I'll send over some stuff.
I will.
Sounds good. Okay, Jamie, I see that you sent over some WebAssign stuff to look at.
Yep.
And then, so some exact values. We got some right angle trigonometry stuff. Nico, I'm going to just start with one of his questions and then obviously get back to whatever you want to work on also. Okay, start with 15 here. Let me share my screen and we'll get started. Okay, find the exact value of the expression. So it starts out with this arc sine -2/3. And really what this is saying is the sine of some angle, which we don't know, is -2/3. You guys know from last time that sine is negative ASTC. So sine could be negative either in the third or the fourth quadrant, but maybe you saw this in class. Arc sine is only good from -π/2 to π/2. It actually runs, it does run from 0, but you kind of go backwards and then forwards. So if that's not clear, that is an important thing here, but that puts you in fourth quadrant. So there's your theta in that fourth quadrant here, and your sine is -2/3. We have to find this here. It's this squared minus this squared, square root of 5, and it is positive here. So it's this angle right here. So the arc sine of -2/3 means the sine of this angle is that right there. And then we want to actually find the tangent of this angle, because we're replacing all of this with theta, and tangent of theta, once you draw the triangle, that's why it says, hey, draw a triangle. Your triangle is -2 over the square root of 5. And you can multiply the top and bottom by √5 if you need to. I'm not sure if that's needed here in this question or not.
Got it. Okay.
So see if that works. Let me know if that did not, it did not get accepted.
Accepted it.
Okay, so that kind of segues nicely into what Nico sent over. There's 3 inverse. So there's inverse cosine or arc cosine. Arc cosine of x, that's the same as this cosine inverse of x. You have to remember, and this is tough because there's so much going on in trigonometry, a lot of memorization. It's good from 0 to pi. So you can't give me an answer that's outside of this window when you're doing it. That's the first thing. And then the second one we did arc sine, arc sine of x. So that's sine inverse of x. That one is good from minus pi over 2 to pi over 2. And it's kind of like tangent, arctangent. The difference is that arctangent, you cannot, it's got a, it doesn't include the two endpoints
Mhm.
because you're dividing by 0 at those. So it's these are the same. The cosine, you got to remember this. I don't really have a good way to tell you to remember it. They might have shown you in class. It comes from actually finding the inverse of sine and cosine and tangent, but that's not important here. What is important is that you remember it because you will use it. Now, again, it's kind of like this. It's like this. Find the inverse. If the inverse cosine, sorry, let me do this. What is the inverse cosine of, negative root 2 over 2? And really what this is saying, it's for what angle is the cosine of that angle equal to minus square root of 2 over 2. So it's really, it's giving you the output of the unit circle. So on your unit circle, there are two places where cosine is negative square root of 2 over 2. That is here at 3 pi over 4, and then also over here at, if you go all the way around, to 7 pi over 4. But, and I mentioned this before, and that's really the core thing here, key thing here, is that inverse cosine is only valid from 0 to pi. So your answer has to be from 0 to pi. So this one can't be it. The answer has to be 3 pi over 4. Now you guys have graphing calculators. If you have your mode in degrees,
Mhm.
and you type in cosine inverse minus square root of 2 over 2, okay, you should get 145 degrees. Like it knows what to give you. So if you want to try that, you can. That only works if you have the calculator. So I wouldn't recommend doing it. Niko, you kind of brought this question up. Are you kind of looking at like these kinds of questions, trying to know how to do them?
Yeah, just kind of the whole idea of those inverse trig
Yeah.
functions and just kind of some examples too.
Right. So the cosine's the most straightforward one. So if I'll have you guys do another one here. Let's say I want you to do cosine inverse of 1/2. Okay, so the process is exactly the same. You go to your unit circle and you say, where is cosine 1/2? So it's there, and it's there. And that angle is pi over 3. And you're welcome to look at a unit circle while you're doing this. And this one is, I guess, 5 pi over 3. Okay. But, and I just, it's really critical. The answer has to be from 0 to pi. Okay, so it can't be this one. Okay, so the only possible answer is this pi over 3. It's saying the cosine of what angle equals 1/2, and that angle, there's many answers, but the only one that works with the inverse is this pi over 3, because it has to be from 0 to pi.
Okay.
Okay, now we get into the more interesting ones, which are arc sine. So let's do sine inverse of negative square root of 3 over 2. So again, this is saying, it's really saying the sine of what angle is minus square root of 3 over 2. This is what you think, but you don't write because it's not completely correct. You think that, and you go over here to unit circle again, and you draw a unit circle, and sine is negative, ASTC. It's negative in the third and the fourth quadrant. So you probably, that's the y value. So you're looking at like that one and that one right there. So this angle, this first angle, drawing a blank here, 4 pi over 3. Does that sound right? I need to look at a unit circle real quick. I got it. Just pulling up the unit circle. Yeah, 4 pi over 3, and then this other angle is 5 pi over 3. Now from earlier, I said that inverse sine is only good from minus pi over 2 to pi over 2. So you could tell me, hey, like neither of these work. And that's right. But there's another way to get to both of these angles. This first one over here in the fourth quadrant, you can get to by going minus pi over 3. And this other one you can get to by going minus 2 pi over 3. But it still has to be between minus pi over 2 and pi over 2. So the answer to this one is minus pi over 3. And if you have that graphing calculator and you put your mode in degrees, okay, you'll get minus 60 when you do that. Just as a double check, kind of a sanity check on these things. So Niko, we'll do one more of these for sine, just to kind of help here. So let's say I want the arc sine of -1/2. Okay, so that's asking again the sine of what angle equals -1/2. You go to your unit circle. We did one just like this. So, you know, while it could be in either of these quadrants, it's going to be in this one over here on the right, the fourth quadrant. Okay, so that's draw our unit circle. That's this angle here, which is 11. It's 11 pi over 6 if you're coming that way. But again, that doesn't work with sine inverse. It's only from minus pi over 2 to pi over 2. So that means you have to get the angle another way, minus pi over 6. So give me some feedback, Niko. Do you need more examples?
No, that makes way more sense. Just kind of using like that, what works for each, like sine, cosine, stuff like that. So that works, yeah.
Okay,
I have
Jamie,
a quick question.
of course.
So like if it was tangent and it was on the like the y line or whatever,
It won't.
it would be undefined, right?
Yeah, you will never be asked to find like a value right along the
Okay.
y-axis because it doesn't exist.
Got it.
It's impossible. Now again, there's all the possibilities. There's cosecant inverse, cotangents, secant. There's all these, right? You got to know them all. I can't do them all here for you. It's good practice. You will see this again in calculus if you guys take this, take that class. So you definitely want to learn this if you can.
Okay.
Okay. Niko, go ahead and send something else over if you would like. I'm
I'll look over.
gonna go to another WebAssign here. We'll go to this 16 that Jamie sent. It's a symbolic one. All right, so arc sine of, so that what you're doing is you're actually saying theta equal to arc sine of x minus h over r. And then if you take the sine of both sides, the sine of theta equals x minus h over r, because sine undoes arc sine. Now it says to sketch a right triangle. Sorry. So this could be
sorry.
Okay. This could be, because we know arc sine is in the first or the fourth quadrant. Somebody decided that. And I guess I'm going to go first quadrant here because I don't like fourth quadrant unless I have to. It is just awkward, but there's theta, it's x minus h over r. So even though we don't do this very often, you can put an expression as the leg of a right triangle. And you generally need the other side. So the other side is the hypotenuse squared minus this squared square rooted. So again, it's a squared plus x minus h squared equals r squared. A equals r squared minus x minus h squared square rooted. So you have to find this expression. You do this in Calc 2, a lot calculus 2. So you just see it again, but by that time it's been forgotten. So remember, all of this was theta right there. I said we're going to make the substitution, and your job is to find cosine of theta. That's why you needed the a, because you needed the adjacent leg. So that is the square root of r squared minus x minus h squared, all under the square root, all over the hypotenuse r. And so everything in this box without the equal sign goes in there.
Got it.
You tend to get either a numerical example like you did in 15, or a symbolic one like 16 on a test, where you have to draw the triangle, find the missing side, and then use the fact that you're just finding the cosine of the angle to write the ratio of the sides in some manner like that. As a kind of a related, sorry, did you get this down, Jamie?
Yep.
I don't, okay. As kind of a related thing, you will occasionally see stuff like this on an exam, like sine inverse of x, or x, it's not x, it'll be like pi over 4 or something like that, or and then the related problem is the arc sine of the sine of x, and again, it won't be x, it'll be like I said, like, sorry, this would be getting too excited here. This is square root of 2 over 2, and this might be like 3 pi over 4. These do not always undo each other. The mistake is to think that they always undo each other. You should work them out the way we did in this last problem set, where you draw the triangle. Do not do that, because it'll inevitably be the one that you'll have to subtract from pi or add pi. They'll just be wary of that. And these are common test questions you might see. So I can give that more. I can explain that more, but let's wait for it to come up if you guys think that will. Again, like if you're like go to your class notes, like what is the instructor emphasizing? That's a great skill to have if you guys are going to college. Like you got to figure out what their hot button is when they're doing this. Okay. So Niko, you sent this question over. Find the period and the amplitude. So if you haven't seen this in class, sine, cosine, and then as related, cosecant and secant, they all have period 2 pi over b. Tangent and cotangent have periods pi over b. You have to know this, like that they're not the same. This one's a little different. B is the number in front of the variable inside here. This one's written a little bit awkwardly. Let's write it out the way we would prefer to see. It's pi over 72 times x. This is your b value right here. That's your period. So your period is 2 pi over 72. 2 pi, when you divide, you multiply by the reciprocal. Period is 144. All right, amplitude, Niko. I'm sorry, Jamie. Jamie, what is the amplitude of this one? You've done a little bit more with this.
Wouldn't it be the 8/9?
Yep. Let's say it was negative 8/9. What would the amplitude be?
Still 8/9.
Still 8/9. So it doesn't matter whether it's positive or negative. The amplitude is the absolute value of this number in front. Does this have a phase shift? Phase shift goes right there if there is one. And the answer is no. There's nothing being added or subtracted inside the parentheses here to show that.
Okay.
So again, just be very wary. Remember this on what I've boxed in here, because you might on a test get a bunch of sine or cosines in a row, and then tangent is pi over b, not 2 pi. All right, so Jamie, I'm going to jump to question 20.
Okay.
The angle of depression from the top of a lighthouse, 230 feet above the water level, to the water line of a ship 2.5 miles offshore. Find the angle. Okay. So here is your picture. Here's a lighthouse. You guys ever been to a lighthouse somewhere?
I personally have not.
They're kind of interesting. They're not used very often anymore, but they're kind of neat things if you ever get a chance to go up inside one. All right, so it's 230 feet above the water. And this is in feet. And 2.5 miles is obviously not in feet. So they're, if you remember that 1 mile is 5,280 feet. So this distance here is 2.5 times 5,280 feet. The angle of depression is up here. You guys took geometry. And so the angle of depression is, this top line is parallel to this bottom line. So these angles are the same. This is the angle of elevation. So you quickly want to substitute in. So you're trying to find this angle. Your options are sine, cosine, and tangent. Tangent's the best choice here because the tangent of theta is the opposite over the adjacent. 230 over 2.5 times 5,280. Always be considerate of the mode of your calculator. Make sure you're comfortable between degrees and radians. This one wants it in degrees. Your theta is the tan inverse of 230 over 2.5 times 5,280. Niko, if you got, it looks like the only thing that might change in your problem would be this red number up here.
Yeah.
Why don't you guys both try that now? Let me know if you don't get the right answer so we can look at it.
Mine was good.
Great.
I'm just substituting my number in.
What was the actual angle there, Jamie? Because I bet it's pretty small.
Yeah, it was like 0.998.
Yeah.
I found that other angle when I did the problem earlier, which was the problem.
Okay.
So
Oh
the-
yeah. Oh yeah. You found this one.
Yeah.
Yeah.
So the angle of depression,
This is the depression.
it's always the same as like the elevation one.
Yes. Yes. I don't know why they don't just tell you that from the beginning, but it's exactly the same. Probably depression is like used in airplane stuff, and elevation is, boats or humans that are looking up.
Yeah.
I don't know. Niko, any issues on your
Mine was good. Yeah.
great. All right, so Niko, have you sent anything else over for us to look at?
Oh no, I just been typing in notes. Let me look
Okay,
at it.
sorry. Yeah, I know we go pretty quickly here. Yeah. Jamie, I mean, we're gonna get through that next question. So there's some other stuff you want us to look at. That would be good. I'm trying to think of other things here that might be relevant to bring up. I'll just draw it kind of so you're in this trigonometry part of your class, and there's really two types. There's right triangles, which you're about to be done with. And right triangles is your Pythagorean theorem. It's your sine, your cosine, secant, cosecant. That's your graphing. Some of these story problems. Okay, but if you haven't, you're about to go into non-right triangles. And you guys saw this probably in geometry. So that's like law of sines, law of cosines, finding lengths, finding angles, finding areas. So if you haven't gotten there, you will be there very, very soon.
Okay.
So let me work through this next two fire towers thing question. I'm going to just snip in the image and then I'll just copy in the numbers.
Okay.
A little wide here for this. So these other letters, this is theta. That's a Greek letter. This is, I don't know, phi or phi, or I don't know what it is, but there's a Greek alphabet out there. If you want it, you can look up that. The angles, it's a little weird how they're giving them to you. They tell you that theta is 16 degrees east, 16 degrees of north. Okay, so like if I'm just guessing here, that's 16 degrees. That looks pretty reasonable. East of north, I don't know, and that's 38. Usually they give you some words like like west of north. But let's just go with that for now.
Okay.
They're 29 kilometers apart. So actually the mistake here, you got to pick one of these is X and one of these is 29 minus X. So let's call this one X. And then this other one, this other length from A to this midpoint is 29 minus X.
Hmm,
And that's this key part of this problem.
got
So
it.
to find the distance here, we're gonna have to write two equations. And we're gonna do it just one for each triangle. So we'll just do this triangle on the left. The tangent of theta, and the reason I know it's theta, I'm gonna do 16, is it's got to be the opposite and the adjacent. It's got to be the ones that we know or have letters for. So it's d over 29 minus x. The one on the right here is tangent of this other letter, 38 equals d over x. So you have two equations and two unknowns. You guys know how to solve this, but I'll point out here that if you solve this first one for x, you get d right away, but that's a little bit harder to do. You have to do a little bit more. So what most students do is they'll solve this for d. D is x tan 38, and then they'll substitute this into the other one. So you get tan 16 equals x tangent 38 over 29 minus x.
Okay.
Then it's just an exercise in solving here. So we multiply both sides by 29 minus x. So 29 minus x times tangent of 16, x tangent 38. On the left here, you distribute 29 tan 16 minus x tan 16 equals x tangent 38. Move this x term to the right. Okay, so you get 29 tangent 16 equals x tangent 38 plus x tangent 16. Factor out your x. Yep.
Got it.
You will get a problem like this on a test potentially. It's solved the same way. And then you divide both sides by what's left over. Niko, you've got different numbers. Your 29 might be something else. Your 16 might be something else. I'm also not completely sure that those are the right angles, although I think it is. But that's how this is generally solved. So x is 29 tangent 16 over tangent 38 plus tangent 16. And your number, you would just change your numbers in here and make sure your mode is in degrees. All right. Is there anything on that one to go over again?
Makes sense for me.
Niko, anything you'd like to cover again on this one?
No, I just been writing down notes, so I'm gonna
Okay.
solve it later on, but yeah, just
Okay.
writing the notes for
Okay.
it.
Yeah. I mean, the key is set up two equations and set them equal to each other. And if you don't like writing tangent 16, tangent 38, you can round it to like 4 decimal places, probably get the close enough with your answer. All right. So let's move to this question that Niko sent me. What you will probably be asked to do on the test is to graph this on your own. It'll be to graph 2 periods. But when we're given the 4 options here, like I would have you write down like the transformations, like what's going on here. And when I look at this, there are actually only 2 transformations. There is a phase shift. And the phase shift is just like inside a quadratic. So if we were graphing a quadratic and I said, well, what does x plus 1 squared do? You would say it goes left 1. Well, this pi over 7, because it's plus, that means it's going left pi over 7. So this, one of these is left pi. Well, actually, they're all kind of left pi over 7. That's interesting. Wow. Okay. Then the next thing here is this 4. This 4 is a vertical stretch, or the amplitude. So this one has an amplitude of 4. So that means it's going to go up 4 and then down 4. So that actually gets rid of everything but this one here for this one.
I have a question, like, how do you graph like key points? Like, where do you start when you're graphing, like
Yeah,
by
this
hand?
is a really good one. I don't know that they would ask you to do this one, but we'll do it because it's kind of a monster here in terms of like what you do. So the first thing you do when you're graphing, if you're doing this by hand, is you first identify the period and then the phase shift. So the period is 2 pi over b. B is 1 in this case, 2 pi over 1, so it's 2 pi. The phase shift we just said is pi over 7 left. So in terms of where you normally start your graph, normally you start cosine at 0, but this is pi over 7 left. So you have a choice. You can either go left pi over 7. So I'm gonna arbitrarily call that minus pi over 7, and that's where I'm gonna start my cosine, or you can go your phase shift plus 1 period. Now, in either case, you need this information because your phase shift is minus pi over 7, or pi over 7 left, plus 2 pi, which if we make a common denominator, it's minus pi over 7 plus 14 pi over 7. That equals 13 pi over 7. So this thing ends. This thing ends here at 13 pi over 7.
Okay.
Okay, and I don't know how, like you get to choose where these are. Like I'm arbitrarily choosing this. These are not to scale, but this thing is going to go from pi over 7. So cosine starts high, goes low, reaches a minimum, and then comes back up. Okay, so first thing is your instructor wants to make sure you can graph 1 period. Most of the time they want you to graph 2 periods. So your next period, you get from adding 2 pi to this to get your second period. So you're adding 14 pi over 7 again to this. So that's 27 over 7 pi. That's what I said. This one's kind of a weird one because it's really, really horrible. But if you go out here, that's 27 pi over 7. And it just repeats, right? It starts high, goes low, reaches a minimum, comes back up, and hits that again. So when you're graphing, this is very critical, is you start with the period and the phase shift. And Jamie, when we did these, whenever that was 2 weeks ago, we didn't do one with a negative phase shift, which I don't like, but you can definitely start there. You could also start this one over at 13 pi over 7 and just gone right 2 periods.
Yeah.
It's up to you. And in reality, these go on forever. Now, we have not addressed the 4, but that comes next. You have to do the period and the phase shift first. Do not do anything else besides those. The next thing is you deal with the amplitude. So this 4 stretches everything. So every critical point here, okay, and I guess I need to answer that question, Niko, better. This point is important. It's the midpoint of these, or the average. So if you add them together, that's 40 pi over 7 divided by 2. So it's 20 pi over 7. Do you see the jump? Like you're going up 7 pi each time. So this is 6 pi over 7. Right, 6 to 13, 13 to 20, 20 to 27. That's kind of a faster way to do it. And then the y value is just 1 and -1 for right now. But we're going to deal with this 4. I'll do that in a different color. You just raise up the 1 to a 4, the -1 to a -4, and the zeros stay the same. So I like to do the stretch, a reflection, and a up or down all at one time, but you got to do this other part first. Maybe they're not emphasizing that in class, but it's really critical that you do that. So now that I've got these points, you just connect them again. make nice curvy lines. Don't draw straight lines. That one kind of got away from me. 2 periods though is what is expected when you do this. And this, this is 4, this is -4.
Okay, that makes a lot more sense.
Okay.
Yeah.
You should be expected to be comfortable doing this with sine or cosine, because you could very easily get one or the other. What's the difficulty of these that you've been seeing in class? Harder than this? Easier than this?
I think I haven't seen much of it since, but
Okay.
it's been similar to that.
For the
yeah.
most part, that's probably like the hardest problem we would get.
Okay. It's always a good idea to go into a test and like know what the hardest thing you could expect to see, rather than saying, well, I hope it's not on there, because you guys can do this. You can absolutely do this. It's a recipe. Steps 1, 2, 3, 4, 5. Absolutely can do it. Okay. I do not see any new content from you guys. I can go on with some more graphing. I can pull up some other stuff. What would you guys like us to do?
Real quickly, can we go over just like briefly like bearings and stuff?
Say that one more time.
Can we briefly go over like bearings?
Bearings. Okay. So
Like a
that's
word problem.
that's like this like north of west
Yeah.
type of thing. Yeah. Okay. So a ship, I'll have to make this up as I go, but a ship heads out from port, and they're going to go 15 degrees north of east. So the way I read this is that they were going east, but then they're turning north of east, so they're off in this angle like this. So that's 15 degrees. Another ship, and they're traveling, I don't know, at they go, I don't know, make up some, they go 120 miles here. Another ship goes 12 degrees south of east. Yeah, they go southeast. Are you thinking of a right angle problem or not?
Kinda, yeah.
Okay, so so let me start, let me do it differently then. So they're I don't know, they're 400 miles away. And ooh, okay, I gotta find one of these to look up, because I don't know that I can make one. I was gonna give you like another angle here. Okay. Let me see if I can do this. All right, let me see here. Okay, so they're 400 miles apart. This is kind of like the one we just did though. And they're both heading to this island offshore. Here's boat 1. Here's boat 2. This is some island. They want to know how far the island is from here, and this distance, and they tell you that this is, I don't know, 12 degrees.
Okay.
So it's actually the same as the one we just did.
Oh, you just have to like set them
Yeah,
equal to each other.
Yes,
Okay.
like that's X, that's 400 minus X. There are other ones where it's like find the missing treasure. I mean, I can look for one here. Right triangle. All right, let me see here. I find one. These are no good. We want like hard ones, but Okay, maybe this is a better one. All right, so I got another question here. I'll snip in. I'm not sure if we can do this yet, but this looked somewhat better. So they give you this diagram on the right. What they don't tell you is that there's a right triangle right there that you can make, and this is X if you want it. So the whole thing is now 290
290 plus X.
plus X. This H we don't know. I think that's one of the things that maybe you end up having to find here. But let's just see what we can do here. So it's kind of the same setup, but if we look at this first triangle on the right, the smaller one, the tangent of 65 degrees equals H over X.
Okay.
Okay. And then if I do this much bigger one, the tangent of 40 degrees is H over 290 plus X. So again, two equations, two unknowns. You can solve this just the same way we did before. You solve one for X or one for H. It's usually the top variable that's better to solve for. In terms of how you find angle A, let me get these numbers for us first, because that will help here, because I think this is the kind of thing you might see on a test. So I'm going to use an online calculator here, and hopefully it just solves it for me. It's loading. Yes, we're assuming it's in degrees. Come on, give me an answer. Ugh. All right. So the answer is one. Let me look here. It's 400, and I believe that's H, and X is 186 when you solve. Okay. So in terms of like how you find angle A, because that's something you could be asked to do. Angle A is just for this triangle. You can find the whole angle though, because you know this big triangle here, you know that this whole thing is 50 degrees. You know that because 50 plus 40 is 90 equals 180. That allows you to find this angle right here is 25 degrees. So A is 50 minus 25. You might be asked to find something like that. I don't know.
Okay.
And then if you know law of sines and cosines, you can also do this problem another way. Is there something else, Niko, that I can answer for you? Talk about 4.7 notes.
I think I am okay.
Okay, have you guys just like if you understand this, you're doing really well. There's this unit circle on the right. There's the sine, cosine, and tangent graphs. Are you starting to see the relationship between them? The sine is the y values on this unit circle.
Yeah.
Cosine is the x values. These are all interrelated. They're really all the same. Like you gotta get this stuff down if you want to do well in this class. Hopefully that's clear. Have you done any graphing of secants and cosecants yet?
A little bit.
Okay.
It's like the same.
You got to graph sine or cosine
But
first.
then you take like from the top of the things, right?
Yes.
Okay.
So like let's just say somehow our sine graph looks like this, not to scale. you would first figure out the vertical asymptotes at the crossings, wherever it crosses the axis. And then you draw these U's there in between. Hopefully you're seeing that in class.
Mhm.
So to do secant and cosecant, you got to graph sine and cosine first. For cotangent and tangent, they're off to the side. They're their own animal altogether. Very different, but this is important. Anything else I can help you out with tonight, guys?
I think I'm okay. Thank you.
All right. Well, thank you so much for scheduling. I appreciate you sticking it out, and I'll see you next time, whatever that is.
Awesome.
Thank
Thank you.
you.
Have a great night. Bye now.
You too.
You too.